Hey, Bowmaths, how much do you weigh? Hey, Bowmaths, how much...
Weighted averages?
No.
You want to practice weighted averages?
that's not
I
what I
think
said.
that's
No,
an
no.
excellent idea. Let's get doing that. Hello everyone, and welcome back to another spicy sode of Bowmaths. Hope you've been having a fantastic day thus far. And today we're going to continue on with practicing averages and weighted averages, which we saw was an interesting way we could use fractions to basically split up different numbers and create a new one that sort of represented the numbers that we started with. If you haven't seen the corresponding lecture video for this, the link will be in the description, so please go watch that first, as the content in that is what we're going to be working with today. And as always, I'm going to be flashing the different questions on the screen, so please pause the video and try the questions out for yourself before we go through them together. Without further ado, let's get cracking. Question 1. Alright, so the first question is a calculate the average question. So all we have to do is just add up the numbers and then divide by how many numbers we had in total. So for part A, we're summing 30, 40, and 65, and then we're dividing them all by 3, because there are 3 numbers in this group. And essentially what we saw that was equivalent to is we're assigning a third to each of these numbers, so we're giving them all an equal weight, and then we're taking those pieces of the numbers and reconstructing a new average. But that is equivalent to just adding them up and dividing by 3. So if we add these numbers up, we get 30 plus 40, which is 70, plus 65, which is 135, divided by 3. All right, so we get that the average of these numbers is 45. Let's move on to part B. So this one, we actually have a negative involved this time, but that's fine. We can add negatives, right? That just means we're essentially subtracting that amount off. So we have negative 3 plus 2 plus 31 plus 40. So that's 4 different numbers we're adding this time, so we're going to have to divide by 4. So negative 3 plus 2 is negative 1, plus 30 is just 30, and then plus 40 is 70. So we're looking at 70 over 4, which we could simplify that down into 35 over 2, and that is the same thing as 17.5. So the average of those 4 numbers, the number that kind of represents all of them, is 17.5. All right, and for this last one, same idea, except now we maybe have a little bit of a additional context on it. So we have Benji got 30% on the test, Wes got 92%, and Tubbs got 100%. So we want to figure out the average of these 3 students, basically kind of what percent represents the entire group of students, right? A little bit of Benji's failure, a little bit of Wes and Tubbs' success. So again, all we do is we just add them up, 30 plus 92 plus 100. And since there's 3 students, we're going to divide this by 3. 30 plus 92 is 122, plus 100 is 222. And 222 over 3, let's maybe just do that on the side here. All right, we're looking at 74. Now remember, we wanted the average, but we have to keep in mind what we're averaging. Here we're averaging test scores, right? So the average isn't just 74, the actual average is 74%. So it's important that we add that kind of unit there to make sure that we still know what we're talking about. All right, so not bad, same kind of process overall. And for some extra practice, create or go and collect some different groups of numbers. So what I mean by collect is maybe, go outside and find like a group of things that you want to look at the average of, right? You go to the store or maybe onto like a website with different data on there, but in any case, collect some sort of numbers and find their average, right? So that's good practice to get a hang of kind of this process and also what the average actually represents. Question 2. All right, so we're given a bunch of true or false questions here. So for part A, I have a group of numbers and both groups are identical except group 2 has an extra 0 thrown in. They'll have the same average since 0 does nothing. Okay, so we're finding the average of 2 groups. Group 1 and Group 2 are almost the exact same, except Group 2 has a 0 in there. So when we're doing Group 2's average, well, when we add the 0, yeah, that does nothing, right? However, Group 2 is going to have more numbers inside, right? It has a 0 in there. So that means instead of dividing by the amount of numbers from group 1, we're going to be dividing by the amount of numbers from group 2. So that is going to affect things. So for example, if I have group 1 is just 1 and 2, okay, their average is going to be 1 plus 2 divided by 2. That's 3 over 2, which is 1.5. But if I take group 2, we're looking at 1, 2, and 0. So if I add them up on the numerator, yeah, I do get 3 again, but the denominator is actually going to be 3 this time because there's 3 numbers here, right? So 3 over 3 is 1. So even though 0 doesn't actually change the sum, we are actually still taking a piece of 0. It's just that a piece of 0 is always 0. But that does mean we're allocating some weight to this, which means we have to allocate less weight to 1 and 2, which means that is going to give us a different number overall, and we get the number 1 instead of the number 1.5. So that means that part A has to be false. They will not have the same average. All right, let's look at part B. If I assign a weight of a half to 20, a weight of a third to 30, and a weight of a third to another 30, the weighted average will be 30. So recall for the weighted average, all we're doing is we're assigning a weight to different numbers and we're multiplying it by that, right? Because we're basically taking the piece of that number and then we just add them all up together. So let's see if we take all these weights, do we get 30? So a half of 20 plus a third of 30 plus a third of another 30, right? You can have two of the same number in a group. So a half of 20 is 10, a third of 30 is 10, and a third of 30 is 10 again, and we get 30. So this is looking like it should be true, right? Because it says the weighted average will be 30. But there's one tiny little detail that we missed here. So pause it, see if you can see what detail I'm talking about. What we missed is that in order to have the weighted average, the weights need to have a specific property. Specifically, they need to add up to 1, right? Because essentially we're constructing a number from these pieces. We don't want to essentially over-represent the numbers or have too many pieces that will exceed the whole of what this weighted average needs to be. So if we add up these weights, are we going to get 1? Well, we have a half plus a third plus a third, so that's a half plus 2/3. A common denominator here is 6, so this is going to be 3 over 6 plus 4 over 6, right? Multiplying these by 3 each, multiplying these by 2 each, and we get 7 over 6, which is greater than 1. It's not equal to 1. So what we actually end up getting is that this is going to be false because even though, yeah, these add up to 30, it's not the weighted average. It's something different, right? Because the weighted average needs the weights to actually add up to that whole, to add up to that 1. So this is also false. All right, so then part C, the average of a positive number and its negative counterpart, so for example, 3 and negative 3, or 5 and negative 5, and so on and so forth, that is always 0. I think this should be true, right? Because if you take a number and you add its negative version to it, well, since they're the same size as each other, just going in different directions, that takes you to 0, right? 3 plus negative 3 is 0. 4 plus negative 4 is 0, because essentially, adding that negative is just subtraction, right? So you're just doing a number minus itself, right? So a number plus its negative version is the same as the number subtract itself, which is always 0. So that means the numerator, right, that sum part is always 0. And then when we're dividing by 2, because we have two numbers that we're averaging here, we're also going to still get 0, right? Since 0 divided by 2 is still 0. So we get that part C has to be true.
Question 3.
All right, so question 3 says Aiden got 60% on his assignment, 90% on his midterm, and 20% on his final exam. Calculate his final grade if, and we have different kind of possibilities for how these different assessments are actually weighted. So the first one says is if the assignment, midterm, and final grade all have the same weight, what's his final grade going to be? So since they all have the same weight, that's equivalent to just taking the regular average. So all we're going to do is take the regular average of the 60 from the assignment, the 90 from the midterm, and the 20 from the final exam. So we're going to add those up and divide by 3 since it's 3 different grades. So this is going to be 60 plus 90, which is 150, plus 20 is 170 over 3. And 170 is not divisible by 3, right? If we add up those digits, we don't get a multiple of 3. So we're going to get some sort of decimal. So let's do this with long division. All right, so we're getting 56.6 repeating, And remember to put that percent sign on because this is a grade after all. So that is part A, if everything has the same weight. But a little more realistically, some things are worth less than others. So part B says, what if the assignment is only worth 10% of his grade, the midterm is worth 40% of his grade, and the final is worth a whopping 50% of his grade? All right, so in this case, essentially we're going to be taking 10% of his grade of 60%. And normally when we were using weights, we were using fractions, but that's fine because we can convert percentages into fractions. 10% is just the same as 1 out of 10. And we're multiplying that by his assignment grade, right? Because the assignment is worth 10% of his grade, so that's going to be times the 60. And then the midterm here, that's worth 40% of his grade. So 40%, that's the same thing as 4 out of 10. And the midterm, he scored a 90 on. And the final, that's worth 50% of your grade. 50% is the same thing as a half, so that's our weight. And because it's applied to the final, we will multiply that by the 20% that he scored. So when we multiply all these out, 1 over 10 times 60, that ends up being 6. 4 over 10 times 90, you can work that out, and that'll be 36. And then a half of 20 is 10. So when we add all these up, we end up getting 52%. So notice that if things are weighted this way, he ends up getting a lower grade. And that might make sense because, for example, the assignment, he did better on that, right? He got 60%. And so in part A, that was weighted more, right? Because it was weighted of a third. Whereas here, it was weighted only a tenth. So the thing that he did better on, it was weighted less, so that would lower his grade. But also, the final, he did worse on the final. Here, it's only worth a third. But here it has a weight of a half, so the final also has more weight to it, and since he did poorly on it, that's also going to be lowering his grade. So that's why we see that the weighted average here is actually lower than the average we calculated for part A. Now let's see how it affects things in part C when the assignment is worth 30% this time, the midterm is worth 20%, and the final is worth 50%. And before we work this out, would you expect this final grade to be lower or higher than it was in part B? I would personally think it's going to be lower because even though the assignment is worth a little bit more, the midterm, which he did really well on, is worth much less. So that means that this high grade of 90% is not going to be very impactful on the final grade. But let's see what happens. So the 30%, that's the same thing as 3 out of 10. And that's being applied to the 60% that he got. And then for the midterm, that's worth 20%, so that's the same thing as 2 out of 10, which is the same as a fifth, and that's being applied to the 90%. And then the final grade, 50%, that's the same thing as a half, which is being applied to the 20% that he got. Okay, so 3/10 of 60, again, you can work this out, but that is going to be 18. A fifth of 90, that should be 18 again. And then a half of 20 is 10. So 18 plus 18 is 36, plus 10 is 46. So Aiden ends up getting a 46% as his final grade if this is the way the assessments are weighted. So as we kind of expected, it is lower than before because of the really low weight given to the midterm that he did quite well on compared to the others. All right, and for some extra practice, just change things up. Change what the assignments are worth, what the midterms are worth, and what the finals are worth, and see how those different weights affect what his final grade would be.
Question 4.
All right, so question 4 says, give an example of 3 numbers that average to 20. All right, so all you have to do for this is just, well, find 3 numbers that average to 20. There's infinite possibilities, but I think the easiest one is let's just stay around 20. If I do 19 plus 20 plus 21, and we divide that by 3, we'll see that we actually do end up getting an average of 20. And maybe that's somewhat intuitive because 19 and 21 are on either side of the 20, and 20 is exactly the 20, so it kind of makes sense that our average should be 20. But another way of seeing why this works, and this is going to be important for part B and C, is let's look at the 19 and the 21 a little more closely. So if I consider 19, 21, and then the 20, what I'm going to do is I'm going to split this 21 up, all right? So I split this 21 up into 20 plus 1, right? That's the same thing as 21. But now I can combine the 19 and the 1, and I'm actually going to get 20. So when we kind of rearrange how this 19 plus 21 looks like by taking 1 from the 21 and adding it to the 19, we see we actually end up getting 3 copies of 20. And that's nice because 20 plus 20 plus 20 is basically 20 times 3, which is 60. But then we're dividing by 3, which undoes that multiplication we just did, and we're getting back to 20, right? So that's another way to show why this gives us 20. And the reason that's important is because that gives us some motivation as to why I actually chose 19, 20, and 21 in the first place. Because I knew 20 was a 20, and I knew the 19 and the 21, being one below and one above the 20, could actually be rearranged to give me 2 more copies of 20. So let's kind of use this idea and see if we can figure out how to do part B. Give an example of 5 numbers that average to 20. Alright, well in this one, we already know 19, 20, and 21 can give us 3 copies of 20. So if we can get 2 more copies of 20, we'll be good to go. And the way we can do that is if we go 2 below 20 and 2 above 20, we can do a similar rearrangement and get those 2 copies. So if I do 18 plus 19 plus 20 plus 21 plus 22, right, so that's 5 different numbers here. And we'll be dividing by 5 this time, right, because that's the average. Then we already know that the 19 and the 21, I can just take 1 from the 21, give it to the 19. So this really is just 2 20s, right? This is going to be a 20 and another 20. But we can do the same thing with the 22 and the 18. All right, so the 19, 20, and 21, we already know that's the same thing as 20 plus 20 plus 20, so that's just what I have right there. But then I split up the 22 into 20 plus 2. So now what I'm going to do is I'm going to take the 2 from that, add it to the 18, and that's going to give us 20. And then the remaining 20, we're going to keep here. So now we see that since we kind of used this symmetry around 20, right, it's kind of the same both below and above in terms of what numbers we included, we see that we just end up getting 5 copies of 20. So this is just going to be 5 times 20 divided by 5. So we're basically taking 20, we're stretching it by 5, but then we're compressing it back down by 5. So that's not changing anything, right? So this is going to be 100 divided by 5, which takes us back to 20. So we get an average of 20 just like we wanted. So now let's generalize this even more. For part C, it says, given any odd number, so that's 1, 3, 5, 7, 9, so on and so forth, how can I choose that many numbers such that they're guaranteed to average to 20? So this is just following the pattern that we see from part A and B. For 3 numbers, the way we can average them is just take the one below and the one above. That's 3 numbers, so the average of that is going to be 20. For 5, we just take the 2 below and the 2 above, and the average of that, once again, gives us 20. So for any odd number, we essentially just take a consecutive amount of numbers where 20 is in the middle, right? Consecutive numbers being like 18, 19, 20, 21, 22, they're just all next to each other, and 20 is in the middle, and that's going to guarantee that the average is 20. All right, so if we just take the odd number amount, so be it 3 numbers, 5 numbers, 7 numbers, and so on, of consecutive numbers, so numbers where it's just all the numbers where they're one after each other, they just come in order, and 20 as the middle number, then that guarantees the average is 20 because we're going to have the same amount of numbers on the right-hand side of 20 as on the left-hand side of 20, which means we can do this trick where we just kind of take the leftover piece, we split up how much it is over 20, so we have 20 plus the leftover piece, and that leftover piece can go into the numbers that are not quite 20, and that'll make them into 20. So then we'll just get a ton of copies of 20, specifically whatever the odd number we chose, that many copies of 20, and then we're going to be dividing by that number again because, well, that's the average, right? So that's going to leave us with 20. So again, with part C, if you're a little confused on the reasoning, just look back at part A and part B and just know that that applies to a more general setting for whatever odd number we choose. And I encourage you to try it. Try it with 7 numbers or 9 numbers or 11 numbers and see that if you follow this method, the average will always result to 20. And if you want to do this for a different number that averages to maybe like 16 or 39 or negative 47, then all you have to do is the exact same thing, except just take the numbers that are centered around whatever you chose, right? If you want 3 numbers that average to 13, well, do 12, 13, and 14, and the exact same logic is going to apply. Just make sure that that average that you're looking for, in this case 13, is actually in the middle of that list.
Question 5.
Alright, so I asked 10 people to give me their opinion on touching grass on a scale of 1 to 10. If I don't want to count Kieran's opinion as much as the others, because let's be real, that boy's never touched grass, and I want to ensure that his score only accounts for 1 out of 100 of the average, what weight do I have to assign everyone else to keep their weights equal? Alright, so I'm asking 10 people to give me their opinion, but I don't want to count Kieran's opinion as much as the others. So I've got 10 people, right? And Kieran is one of them. So Kieran and 9 others. And the weight I want to give Kieran is 1 in 100. So that's how much I want to assign to his opinion. So that means how much is left for the others in order to actually get a weighted average, keeping in mind that the weighted average needs all the weights to add up to 100. Well, since we've used 1 out of the 100, we have the remaining 99 of the 100 weight to distribute to these 9 other people. But we want to make sure that their weights are equal, that they have the same weights as each other. So we need to somehow split this 99 out of 100 up evenly over these 9 people. Since everyone's going to have the same weight, we're essentially doing 9 times some weight, and that is going to have to equal 99 out of 100, right? If they all have the same weight, that's the same as just taking that weight 9 times, and we want that to equal this remaining 99 out of 100. Well, this isn't bad because we know 9 times 11 out of 100 will give us 99 out of 100, right? 9 times 11 is 99, and technically this is 9 out of 1, right? So the denominator is multiplied to 100. So if we give everyone else's opinion a weight of 11 in 100, then we're just doing 9 of those, which gives us the 99 in 100, plus Kieran's lesser weighted opinion, which is 1 in 100. That's going to add up to the total of 1 that we want. So this is the way that we would make sure that we're actually getting a weighted average with the specifications necessary.
Concluding thoughts.
Okay, so that's going to do it for today's video. I hope you found it useful. I hope you're feeling more comfortable with averages and weighted averages. I think there were some pretty interesting questions, some a little more challenging than others in today's video. And yeah, let me know how you thought in the comments. I'd be interested to hear. And lately, Bowmass has been popping off a little bit. I've been getting a lot of support, especially on the Minecraft re-upload videos. So thank you so much for all of your support, and I hope to continue making videos that you find useful. And yeah, until the next one, you have a good one, you stay groovy, and I'll see you in that next video. Man, I love Bowmaths. He's so cool. I'm just gonna watch him all day long, I think. And like probably comment and subscribe too. Yep. I love Bowmaths.
Bowmaths.